Slim Jim is also an astronaut. The acceleration due to gravity on the moon is 1.63 meters per second squared. So this is our new acceleration due to gravity. Jim is lifting a 20-kilogram object from the ground with rope. What is the weight of the object on the moon? Well, we know the force of weight is equal to mass times gravity. Now, this object is 20 kilograms. It has a mass of 20 kilograms. On Earth, it would have a mass of 20 kilograms. In space, it would have a mass of 20 kilograms. But, because our gravity is different on the moon, our weight would be different on the moon. So this object that has a mass of 20 kilograms is going to have a weight of 20 times 1.63 newtons on the moon. Let's grab our calculator. 20 times 1.63, and that gives us 32.6. So where it would weigh a lot more on Earth, it only weighs 32.6 newtons on the moon. Alright, now it wants us to draw a free body diagram for the mass below this picture. So this mass only has two forces acting on it. It's got the force of this rope, which we know to be called a tension force, and then also the force of weight, which we just calculated. So we have the force of weight, and we have tension. So we've done that. If Jim can pull upward with a force of 300 newtons, calculate the acceleration of the mass. Alright, well, we know that the sum of the forces, the sum of these forces, tension, which is up, and force of weight, which is down, is equal to mass times acceleration. And we know the sum of the forces is, since T is up, it's going to be positive, and since the force of weight points down, that's going to be negative force of weight, or minus force of weight. And then our mass is 20 kilograms, and we're trying to solve for our acceleration. We know that the tension, the force that Jim can pull upward, is a force of 300 newtons. And we know the force of weight is 32.6 newtons. And that the mass is 20, and we're trying to calculate our acceleration still. Okay, 300 minus 32.6 is 267.4. So we have 267.4 newtons, which is actually our net force. The sum of our forces equals 20 times A. So to solve for acceleration, we have to divide both sides by 20. Here, 20 over 20 cancels out. So our acceleration equals 267.4 over 20. We have our 267.4, and we can divide our answer by 20, and that gives us 13.37 meters per second squared. So it's accelerating very quickly. And we're done.